This video is going to cover how you use the unit circle to come up with answers to various trig problems. This is Learning Target 5. I can use reference angles to find a trig value. So what I have here is a blank unit circle. I want to find the sine of 225, cosine, and tangent of 225. To do this, I need to understand where the 225 is. Here is a completed unit circle. I see that 225 is right here. So when I draw my angle in standard position, I'm going to draw it like this, which leads me to this coordinate. So once having a completed unit circle and understanding where the angle given lies on that unit circle, the unit circle gives us a coordinate that we can use for our sine, cosine, and tangent problems. As discussed earlier, we discovered that cosine is our x's and sine is our y's. So each of these values are answers to cosine and sine. So let's draw this in standard position. Here's the initial side and my terminal side. And this is 225. What is my reference angle? My reference angle is 45 degrees. What's the coordinate here? The coordinate was negative square root 2 over 2, comma, negative square root 2 over 2. Remember that the x's are my answer to cosine, and my y's are my answer to sine. So my answer to sine of 225 is the negative square root 2 over 2, which is the y. And from my cosine, it's also negative square root 2 over 2, which is my x. The tangent would be my opposite, which is square root 2 over 2, over a negative square root 2 over 2, which ends up equaling 1. These are my three answers. Let's try finding the sine, cosine, and tangent of negative 300 degrees. Let's take a look at our completed unit circle. Positive 300 degrees is here in the fourth quadrant. So if I went negatively, that would be going spinning down. I would end up at 30 degrees, which is negative 300 degrees. Here's the coordinate I need to use. So let's draw that one more time. Initial side goes around to my terminal side. My reference angle is 3 degrees. So where is this coordinate? This coordinate is at x square root 3 over 2 and y 1/2. So my sine is my y value, which is 1/2. Cosine is my x value, square root 3 over 2. And tangent is my y value of 1/2 divided by my cosine value of square root 3 over 2. I do want to complete this. So remember how we simplify our fractions. This turns into the multiplication of the reciprocal. 2's are gone. I now have 1 over square root 3 over 2. We're going to rationalize the denominator. And so my final answer would be square root 3 over 3. These are my three values. We can also use what we've learned about the unit circle to solve for the sides and give trig ratios on triangles beyond the unit circle. So in this scenario, I have an angle called theta. This angle is in the fourth quadrant. I know what the tangent of angle theta is. It's negative 4 over 3. Let's find these other values. We can do this by drawing this out. So I'm going to draw a triangle in the fourth quadrant. It doesn't really matter what this triangle looks like, just as long as the terminal side is in the fourth quadrant. My angle is this angle. This is my theta. But let's refer to my missing angle as my angle x. What sides were I given? Well, I was given a tangent, which is opposite over adjacent. So for this angle x, I am given a opposite of 4, and since this goes down, this must be the negative 4, and a adjacent of 3 goes right, so it should be positive. How do we find out the last side of this right triangle so that I can do sine and cosine? Well, let's use Pythagorean theorem. 3 squared plus 4 squared equals y squared. 9 plus 16 equals y squared. 25 equals y squared. So my y is equal to a 5. So my hypotenuse in this problem is 5. Now I can give my answers for sine. Sine is opposite over hypotenuse. Opposite is negative 4. Hypotenuse is 5. Cosine is adjacent over hypotenuse. This would be positive 3 over positive 5. And to find my theta, all I need to do is inverse any of these to find out what it's equal to. Let's inverse the tangent. So my theta would be equal to inverse tangent of 4, don't forget the negative, over 3. The theta I end up with is negative 53 degrees. But since I want to know the positive of this, not just the negative version going down, what I'm going to do is I'm going to take 360 degrees and I'm going to take away 53 from them. I end up with 103. 103 is my positive angle. 53 is the negative angle going clockwise, but going counterclockwise is 103. Let's try this example one more time. In this scenario, I have a theta, an angle, which is in the second quadrant. Let's start by drawing a terminal side in the second quadrant. So this angle right here will be my theta. Again, finish your triangle and put an X in the reference angle that you're going to find. Let's label the sides of this triangle that we're given. We're given the opposite over the hypotenuse because this is sine. So I'm going to put 15 on the opposite side and 17 on the hypotenuse. So my missing y side is the side I need to get, which is the adjacent. So let's use Pythagorean theorem. 15 squared plus y squared is equal to 17 squared. 225 plus y squared is equal to 289. Y squared is equal to 64. So my y is equal to an 8. Now since this y side is going to the left, my y is actually a negative 8. Now I can find all the missing trig ratios. Cosine is adjacent over hypotenuse, which is negative 8 over 17. Tangent is opposite over adjacent. Opposite is 15, and adjacent is that negative 8 I found. Now I can inverse the ratio I was given in the beginning to figure out my missing angle. So the inverse sine of 15 over 17 is equal to about 62 degrees. Now let's see if this makes sense. In the second quadrant, I have angles that are bigger than 90 degrees. So this is actually the reference angle. To find the actual theta angle, I will have to subtract this out of 180 degrees. That will be my theta. It is 118 degrees. I have one last kind of example to show you. I want you to realize that there are multiple spots on the unit circle that have the exact same value for sine and cosine and tangent. The sine of what other angle between 0 degrees and 360 degrees has the same value as sine 315? Here is a completed unit circle. Let's find out what the sine value is at 315. Here is 315, and my sine is a y. So Where else on the unit circle is there a y of also negative square root 2 over 2? Well, that would be right here, which is at 225. So the answer to this question, what other angle? The other angle is 225. Let's try this one more time. The cosine of what other angle between 0 and 360 degrees has the same value of cosine at negative 210? Let's find negative 210. If I spin positive clockwise at 210, I end up here. Therefore, if I spin negative, which is just normal clockwise, I would end up right here. The cosine values are the x values. Where else is there an x value of negative square root 3 over 2? That would be right here, which is at positive 210. So, what other angle has the same value for cosine as the cosine of negative 210? It's actually of positive 210, but also 150. I would accept both these as correct answers. That covers it for these notes and examples. If you have questions, make sure you write them down in your left-hand column and you ask them to me or you ask them to your group. Don't forget to hit the submit button so I have a recording of you watching the video.